Hi guys, this should be the last video for this test, and it's on absolute value inequalities, which is on section 2.7, I believe. Okay, so when we're talking about absolute value, just like I talked about in the absolute value equations video, the definition of an absolute value is a number's distance from zero. So the absolute value is a number's distance from zero. Now, when we're doing this, and I changed this to an inequality, okay? So let's say I had the absolute value of x is greater than 2. So what I'm saying here is that a number's distance from 0 is greater than 2 units. Okay, so if we look at a number line and I put 0 in the middle, here is a distance of 2 units. So if I am looking at just the number line and on the positive side, where is that distance from 0 bigger than 2 units? Well, the distance bigger than 2 units is somewhere out here because 3 is bigger, 4 is bigger, 5 is bigger. And remember that that's a distance, okay? Now, forget that side, and you want to look at the left-hand side. So over here is a distance of 2 units. Where is that distance greater than 2 units? Well, it's somewhere out here because this would be a distance of 3 units, a distance of 4 units. Okay? Now, looking at this graph, and again, this one would have parentheses because we don't have an equal to on the greater than. All right, looking at this graph, it's going to tell me how to change this absolute value into 2 inequalities. All right, the first one is just x greater than 2. Now, when we were doing compound inequalities, the word that kind of connected 2 pieces of a graph was the word or. Okay, and then this piece of the graph here is x less than negative 2. So anytime that you have a greater than absolute value, you're going to set up 2 inequalities with the word or. Okay, and the first one is set up just like you have the absolute value with no absolute value symbols. The second one is set up with the opposite inequality sign and a negative on the number. Okay, so let's do an example. If I have the absolute value of 2x minus 1 greater than or equal to 5. Okay, so my first inequality is going to be 2x minus 1 greater than or equal to 5 with the word or, and then I'm going to set up 2x minus 1. I'm going to flip this inequality sign, and I'm going to flip the sign on the number. Now I can set up 2 inequalities so that I'm going to solve them. I'm going to add 1 to both sides and get 2x less than or equal to negative 4. Divide both sides by 2, and I get x less than or equal to negative 2. On the right-hand side, I'm going to add 1 to both sides so that I get 2x greater than or equal to 6. Divide both sides by 2, and I get x greater than or equal to 3 with the word or in the middle. Now, it's really important that you put the word because I cannot give you credit unless you set up the correct inequalities with the correct signs and the right word. Okay? So if you don't get that part, then I can't give you credit for the problem at all. All right? So make sure that you're setting them up correctly. Now, when you get here to the answers, you're not done, because in the directions it says graph or solve, graph, and do the interval notation. Okay? So now when I get to here, I can do the 3-line method. That's why we did the 3-line method in the compound the inequalities. So I'm going to set up x less than or equal to -2, x greater than or equal to 3, and then the or. Alright, so I've got -2 on the left, +3 on the right. So if I do less than or equal to -2, that's going to be a bracket on -2 shaded to the left. And x greater than or equal to 3 is going to be a bracket on 3 shaded to the right. Remember that OR shades everything in both graphs, so that I have everything shaded here, everything shaded here. And when I go back to do my answer, it's going to be everything that I've shaded, which is everything less than or equal to 2, everything greater than or equal to 3. And then the interval notation, remember, is reading from left to right. So this graph starts at -2. At negative infinity and goes to -2. I skip some space, so I'm going to put a union, and then picks up again at 3 and goes to infinity. All right. Let me do another one of those just so you can see. And I'm going to make this one a change where you have to divide by a negative. So let's say that I had 2 minus 3x greater than 4. All right. Again, the setup is the exact same way no matter what, since it's a greater than. We're going to have 2 minus 3x greater than 4, just like the original, except without the absolute value signs. The word in the middle is or, and then I'm going to set up 2 minus 3x, flip the inequality sign, and flip the sign on the number. All right, so when I go to solve this, I'm going to subtract 2 from both sides, and I get -3x less than -6. Now here I'm going to divide by -3. And when I divide by a negative in an inequality, remember it's got to flip that inequality sign. So we'd have x greater than +2. I'm going to subtract 2 from both sides, so I get -3x greater than +2. I'm going to divide, divide both sides by -3. But because I divided by a negative, I've got to flip that inequality sign. So I'm going to have x less than -2/3, and the word in the middle is or. Again, I'm going to draw my 3 lines. So I have x greater than 2, x less than -2/3, and the or on the answer. So this time I've got -2/3 on the left, +2 on the right. All right, so I've got x greater than 2, which is parentheses to the right. X less than -2/3 is going to be parentheses to the left. Since this is or, I'm shading everything in both graphs. So I'm shading everything here, and I'm shading everything here. So when I come to do my answer, it's going to be everything left of -2/3 and everything right of +2. So my interval notation, looking from left to right, is going to be from negative infinity to negative 2/3. Stop, skip some space. I'm going to pick up at 2, and I'm going to go to infinity. All right, I just wanted you to see that even though the negative is inside, that you're still going to get a proper greater than absolute value graph. I have people that make the mistake here that they divide by that negative on one and they forget divide by the negative on the other one, and they get the graph going the same way. Even though it's you're dividing by a negative, you're still getting a proper graph. And I like to say that the absolute value greater thans fly like eagles, because you're going to go in opposite directions. All right, so let's do a less than. All right, so if I look at this, and I'm just going to do one in general, let's look at the absolute value of x is less than 4. All right, if I go to a number line, again, we're talking about a number's distance from 0 is less than 4 units. Okay, so if I look at the number line with 0, now here is a distance of 4 units, and I'm just looking on the right hand side of 0. Where is that distance from 0 smaller than 4 units? It's somewhere in between here. Like, that would be a distance of 3, which is smaller than 4. That would be a distance of 2 and a distance of 1. Okay? Now look on the negative side. People really mess this up because they'll say that it's somewhere out here because those numbers are getting less than negative 4. But that's not true, because we're not talking about their number like negative 5, negative 6. We're talking about their absolute value. So that distance back here is actually getting bigger and further away from 0. So the actual distance where it's getting smaller is somewhere in here. Because if this is a distance of 4 units, then this would be a distance of 3 units, which is smaller than 4. That would be a distance of 2 units, and that would be a distance of 1 unit. Okay? So, when we think back to compound inequalities, we can see that this was more associated with the word and. Now, here's where people differ on the way they decide to set this up. And it just goes on the fact whether you're more comfortable with one or the other. Okay? So people can set this up as x less than 4 with the word and in the middle. And it's kind of the same thing. You flip the inequality sign and you flip the sign on the number. All right, just like we did with the greater than problems. The other way this is set up is, see how it's trapped in between negative 4 and positive 4? So we could write it as the compound inequality negative 4 less than x less than 4. All right, it just, whatever you feel more comfortable with is the way that you need to set it up. So I'll do both for both of my examples just so you see they come out to be the exact same answer. Okay, so let's do an example. Let's say that I have the absolute value of x minus 3 less than or equal to 8. All right, so here's where I'm just going to divide this into 2 pieces. All right, so if I'm doing the compound inequality with the word and, I'm going to set up x minus 3 less than or equal to 8 with the word and in the middle. X minus 3, I'm going to flip the inequality sign to greater than or equal to, and I'm going to flip the sign on the number. Then I can add 3 to both sides, and I get x greater than or equal to negative 5. Add 3 to both sides, and I get x less than or equal to 11 with the word and in the middle. All right, so when I go to do the 3-line graph, I'm going to have x greater than or equal to negative 5, x less than or equal to 11, and the word and is my answer. All right, so here I've got negative 5 and 11. So x greater than or equal to negative 5 is going to be a bracket to the right. X less than or equal to 11 would be a bracket to the left. The word and says shade what they have in common. So I'm going to shade everything where they overlap. So my answer is between negative 5 and positive 11. So my interval notation would be from negative 5 to positive 11. Okay, so let me show you that as just the compound inequality. So since it's less than, we would set it between negative 8 and positive 8, just like that. And then I would add 3. Add 3. I'm going to get negative 5 less than or equal to x less than or equal to 11. Now, I really only have to set up one number line. So I have negative 5 to 11 with brackets on each end. And I would have negative 5 to 11. Okay? Let me say this, because I'm going to have somebody try it. You cannot do this for greater than. Okay? You cannot do it for greater than because the symbols don't mean or. The symbols mean and. Alright? So let me do another one, which you're going to think that I'm crazy because it's going to work out a different way. Alright? So let me do one with a negative. Alright, so let's do the absolute value of x plus 2. No, let's don't do that one. Let's do 2 minus x. Absolute value of 2 minus x less than or equal to 7. Alright, so 2 ways. With the and, we're going to set up 2x, 2 minus x less than or equal to 7 with the word and, then 2 minus x, flip the inequality sign and flip the sign on the number. Then I'm going to subtract 2 from both sides, so I get negative x greater than or equal to negative 9. Now I need to divide both sides by negative 1. But because I divided by a negative, I have to flip the inequality sign. And that's going to give me positive 9. On the right-hand side, if I subtract 2 from here, and I'm going to subtract 2 from here, I've got negative x less than or equal to 5. Then I'm going to divide by negative 1 on both sides. But because I divided by negative 1, I have to flip the inequality sign. And I get greater than or equal to negative 5. So when I come down here and do my 3-line method, I've got x less than or equal to 9, x greater than or equal to negative 5, and then the and as my answer. So I've got negative 5, positive 9. Now, when I do x less than or equal to 9, it's going to be a bracket shaded to the left. X greater than or equal to 5 is going to be a bracket shaded to the right. And is where they overlap. So where did they overlap? Here in the middle. So my answer is from -5 to 9. And you can say that with your interval notation. -5 to 9. Now, when I go to the setup for the other one, I would set it up between -7 and 2 minus x and +7. So I'm going to subtract 2 from both sides. And I get -9 less than or equal to -x less than or equal to 5. So now I need to divide both sides by -1. Now, remember, because I'm dividing by a negative, these inequality signs have to flip. Okay? So I've got greater than or equal to, and that's still going to be +9. And that's going to be +x, and that's going to be -5. Now, if you turn this upside down, and you look at it from the upside down, all right, it says -5 is less than or equal to x, which is less than or equal to 9. So x is bigger than -5, but it's less than 9. Okay? So when you do this, you're still getting that it's bigger than -5, but it's less than 9. So it's bigger than -5, but less than 9. Okay, so still the same, -5 to 9. Do not do the absolute value greater thans as the three-way inequality. Do not. Does not work, because greater thans are ors, less thans are ands, and the three-way inequality is an and. Okay, guys, this is the last thing that I think I need to teach for the test. Remember that the test on equations only and the word problems is tomorrow. The test for inequalities will be on Tuesday. All right. I will extend the homework so that all of the inequality stuff is due Monday night, so that you won't have to worry about that. But please, please, please make sure you do all of your homework for equations by tomorrow, so that you have that opportunity to get a 100 on your test. Just let me know if you have any questions.